let's talk about caching in Next.js. This is probably one of the most requested videos that I've had, and I know y'all want to see some practical examples of how to cache data and revalidate data, and also just walk through how the model works from the ground up. So that's what we're going to do today. I'm going to show some examples, show some demo apps that will have the code open source as well too, and kind of walk through the foundations of how caching works in the Next.js App Router. Okay, let's start by looking at an example of an application that uses caching, it revalidates data, and it has mutations, so we can work backwards from a real product. So on the right, I have this example of kind of a roadmap feature prioritization app. And if I go in here and I say new feature, I hit enter, this data that is now shown on the page is being cached. And anytime I make a mutation to this data, like upvoting a feature or adding another new feature, the Next.js App Router is able to revalidate that data. It's able to mutate the cache and update it with the latest features. So now if I reload the page, I still see that we have our cached data on the page. Now, this is a simple example, but it really is probably the most common way of interacting with the App Router. And we're going to break down how every bit of this happens, from static pages to the cached pages, and finally to revalidating data. Before we jump in, I want to talk a bit about the state of caching in Next.js today. So the App Router has been out for about a year now, and a lot of y'all have shared a lot of great feedback with us on the parts of caching that you like, the parts of caching that you want us to change, and how we can improve the developer experience, and even helped report and solve some bugs along the way too. And maybe the last time y'all tried out caching, some parts of this model might not have been ready yet, like server actions or revalidate tag or revalidate path. So if you haven't checked it out in a while, definitely come into this video with a fresh set of eyes, because it might look a little different than the last time you checked it out. And as you'll see as I talk through the video, there's still ways that we want to make this even more simple. So I'll highlight a few things that we're still working on along the way to simplify this even further. Okay, so now let's talk about some of the foundations of caching and of the App Router so we can understand how the pieces fit together. We'll talk a little bit about static and dynamic pages, or static and dynamic rendering. We'll talk about some differences with the pages router model that you might have used before. And we'll also walk through some examples of different use cases where you might want to use caching and what that would look like. So let's start with static and dynamic rendering. So in my application, in my editor on the left here, I have a App Router app, and I have a page at the index route. And this page is just rendering out some JSX, and it's rendering out the date of right now. And in my terminal on the bottom left, I'm running Next.dev. So on the right in the browser, if I reload the page, I can see I'm making requests to this page, and I'm getting a new date on every request. Now, this functionality of being able to refresh the page when you're running your local dev server and see up-to-date data is how Next.js has worked since the pages router as well too. I also have, just to show an example, this /test, which is in the pages router, that does basically the exact same thing, except it's passing the date from getStaticProps. And when I'm running in my local dev environment and I reload the page, I see that exact same behavior too with the pages router. Now, what you're witnessing is that when you're running local dev and you reload the page, even though this page is going to be cached, and we're going to talk about that here in a second, the data is fresh on every reload. And I think sometimes that foundational bit gets a little bit confused between folks trying out this new model. So we have to understand that bit first. For example, if I were to go and run the build and then start my application locally, you're going to witness a different behavior. And what you're going to see is when we run a production build, when we take this example of our App Router page where it had a date, this code, while it is a server component, is going to be evaluated during the build. So there's nothing in this component that's saying that it needs to access any information on demand or from the request. So it can be pre-rendered, and it doesn't need to be computed on the fly. So if I reload the page, I now see this date that has been generated, the page has been pre-rendered, and nothing changes. So this is a foundational bit to understand, which is that even though we're using server components, the default is that pages get pre-rendered when you run a build. It's also worth mentioning that this same thing applies to route handlers that use a GET and do not read anything from the incoming request. So if you try to use a route handler and you want to just print out a date, you might notice the same behavior. Route handlers are built on the same foundation as pages, so they share the same default behavior. Now, what if this isn't the behavior that we want? What if we do actually want our page to be computed dynamically, to run dynamically on every request? Well, we want it to be dynamically rendered and not statically rendered. Now, I've updated my code on the left here to read something from the incoming request. So I'm using this cookies function, which allows me to look at the incoming request. I could have also used a headers function, or we also have one called noStore, which allows you to do basically the exact same thing, to opt into dynamic rendering. And now when I reload my page on the right, you're seeing that this component is getting a fresh date on every reload. So now the page is using dynamic rendering. And there's a number of ways when we talk about fetching and caching of how you can opt out of using the default behavior where things are cached, but it's important to understand this difference from the start. Okay, so with an understanding of static and dynamic and what is opting a page into dynamic rendering, and an understanding that the local Next.dev environment is different than running your production server, let's talk about some specific examples of how you would fetch data and how caching will affect that. So we're going to start with the most simple example, which is using the fetch API. So here I have the fetch API. I'm making a request to some external URL. I get back the JSON, and then I'm showing the stock on the page. So in the right, my browser, if I reload the page, I see in my console that this is a cache hit. I can reload the page, still seeing a cache hit. Now, I have an option turned on in my next config that allows me to see more information about the URLs that I'm fetching from. If y'all think this is helpful and you want us to do more like this in the terminal, definitely let us know. But that's where you're seeing that. And then it's getting rendered out on the page as well too. Now, let's say when I'm testing locally, I want to empty the cache and I want to get fresh data. You can use Command-Shift-R, like a hard reload in the browser. If I do that, now we see in the console that it was cache skip. And now if I reload, I'm back to cache data again. So if you need to clear that out, Command-Shift-R is your friend. What about if you have a fetch, but you don't want it to be cached? Well, going back to the foundational part I talked through with dynamic rendering, we want to tell this component, actually, we don't want to store this in the cache. We want to use noStore or cookies or headers or looking at search params or a number of different ways that you can opt into dynamic rendering. noStore is the easiest. So here I've opted this into dynamic rendering. I said, you know what? Don't cache this. So if I reload my browser on the right, you see every single time I'm seeing cache skip. So this is the really easy way to opt out. Now your next question might be, that's great. The fetch API is super helpful if I'm using some external API, but what about if I'm trying to build my full stack app in Next.js? I want to just go directly to the database, or I want to use some library that doesn't expose the fetch API. The answer for that is a function called unstable cache. So let's take a look at this. In this example, I have /unstable cache route here. Pretty much the same exact thing where I have this product quantity component, but I'm making this call to this get product function. Let's take a look at what this looks like. So I have this unstable cache function, and it takes in this function here where I'm going to go to my database using a Postgres database. I'm going to select from the products table, and I'm going to find the one with the ID of 1. And then I'm tagging this cache to say that this is for all of the products that I'm fetching. So if I go back to my browser, I reload the page, this is being cached every single time. And if I wanted to clear the cache, again, I can do a similar thing where I go and fetch that from the origin source. Now, you might be wondering, is it okay to use this? Can I use this? Is unstable cache fine? The API structure here might change a little bit, and we're looking for your feedback on the overall structure of this. We've already heard feedback that it's a little confusing why there's the parts that make up the cache key here, and then how you're specifically tagging the cache to revalidate the cache here. So we plan to simplify this a little bit, but the general idea is still very solid. So if you have your data layer in your application that has your database and it has your fetches and your functions, and you want to use unstable cache, this is totally fine. And you can still kind of build out your application in this model. And then over time, as we improve this cache in the coming months, we'll provide code mods and documentation and and examples to move from this world to the newer world. Now, if you're like, you know what, actually, I want to go to my database, I want to grab new data, I don't want to cache anything here, that's fine. You don't need to use the unstable cache function. Instead, you can write your component like this. I've just kind of inlined that database fetch here. So go to my database, I select all the products, and then I have a list of products. So on every reload, I'm going and fetching that new list of products. Now, the counter to this is how we actually invalidate the cache when that data changes. And we're going to talk about that a little bit more here in a minute. All right, let's take this a little bit further. So I have a route here. It's a dynamic route that's a list of products. And inside of that page, I'm getting a product based on the ID, and then I'm showing the name and the price. So I have /product/2, /product/1. I have different data depending on what I'm reading from the parameter, from params.id. And this get product call, if I go look at this file, get product, again, it's using unstable cache. It's fetching from the database, and it's tagging it with products. Now let's show what the mutation side of this looks like. And to show that example, I have a route here that is /dashboard. Let's take a look at this code. So /dashboard, it has some JSX, it has products, it has a link back to all products, it has a list of the products, and then it has a form to actually create a product. So I can go back here, I can look at all the products, the same list is here, and then I also can add in a new product here. Now, when I submit this form, I'm going to use a server action. So I have this action called create product. Create product, I'm just putting it inline here, but it's probably best practice to move this to its own file where you can have your own data layer where you can add in security checks as well too. For the sake of simplicity in this example, I have it here. So I mark it with the useServer directive to mark this as a server action. I do a mutation on the database where I insert a new field into the database, and then I'm going to revalidate the tag of products. Now, what I want to show is when I add a new product and I'm able to revalidate this data, how it revalidates data that's been tagged across different pages as well too. So when you call revalidate tag, it's actually purging that entire cache. So let's say I want a new product here that's going to be beef, and let's say the price is 50. I hit create. You're going to see not only does this list of products update because we've revalidated the tag, also if I go back to all products and I fetch this data, we also see this updated with the latest list. So even going kind of cross navigation as well too, I had a mutation that I was controlling in my application. I said this data changed, my database had a new item. I call revalidate tag or revalidate path, and now I can see that latest information updated. Now the follow-up to that is, what do I do when there's a mutation that someone else made on my application? So maybe I went to a CMS and I updated the data. Maybe the data changed in my database. This is where webhooks can come in very handy. So I have a webhook in my application using a route handler. And what I'm going to do to demonstrate this is I have my application here, product/1. And right now, if I reload the page, the price is 9. So what I want to do instead is if I call this webhook, simulating some external event in my system changing, something in my database has changed, I want to go and I want to revalidate the tag products, and then I want to return back. So this takes a post request to my application. So I'm just going to open up a new terminal here. I'm going to make a post request, and I get success back. So now if I go here, I reload the page, I get this new data fetched from the database. So even if that mutation is happening outside of my user interaction, clicking a button, if it's happening from an external system, revalidate tag can still revalidate that whole data. Now, the last bit here is what happens if neither of those are possible? What happens if it's not something that I control, or it's something I can listen to from my database or my CMS? And this is where we're still hoping to get feedback and iterate on this experience today. I'll link a thread down below where we have a deep dive into how caching works today and walks through a lot of these bits as well as our caching documentation. And if you're in this third camp right here, we'd love to hear your feedback on how to make this better. We do have an option that we're proposing to configure this a bit more, so we'd love to hear your use cases around this. If you have cache data that you want to periodically revalidate using the incremental static regeneration like behavior, you can also do that either using the fetch API or using unstable cache. So today, the way this works with the fetch API is that you can pass additional options by extending the fetch API. So maybe I want something like this. We're actually looking to move away from extending the fetch based on your feedback and the community's feedback. So in the future, we'll have a way to code mod or to upgrade this where you can have something like revalidate after, and you can put time in, or an API that looks something similar to this. But for today, it's totally okay to use it this way. We'll give some more guidance as that changes in the future, but I wanted to just mention that as well too. And also on the unstable cache function, if I go back to get product, inside of here, this option not only has the ability to tag the cache, but also to set a revalidate time when you're using unstable cache as well too. So that's how you can use incremental static regeneration, like ability to update cache data based on some time interval. The last one I want to talk about, walking through the foundational examples of how these bits work, is the React cache function. So different from the Next.js cache function, the React cache function, you can kind of think about it like memoization on the server. So I call the same thing with the same inputs. I can essentially dedupe that. Now, this is important because there's some instances in the Next.js App Router that kind of are pushing you towards a model where you're calling the same function multiple times. And that's okay. We've given you these helpers so that you can have control over the cache state of how I call a function and have it not get called multiple times. So for example, on this page, I have this call to get products. So it's going to my database, and I'm using the same call both to generate the initial metadata for the page, like the title, and I'm using it to display the name of the product on the page. And when I go look at get products, I'm wrapping that function with the React cache function. So it's only going to be ever called once, go to the database, and I get the information. So I reload the page here on the right. In the console, I see get products 1, and then I see this page get displayed. I reload. Again, I only see one call to get products, even though you can see apples displayed in the title and it's displayed on the page. So I wanted to mention that one as well too. All right, now I want to show another example of a CRUD app, or a create, read, update, delete, that's using forms, showing some of this in practice a little bit more. But first, I want to talk about the architecture a little bit. So coming back to the differences between the pages and the app router, I think this diagram hopefully explains things well. So with the pages router model, let's start there. You would write code in a client component. Everything was client components in the pages router. And you would have some event handler like on submit. That would call an API route where you would go update your database or update some source. And then that API route could return back some JSON where on the client, you could handle this response and update the UI. In the app router, it's actually entirely different. It's server-based. So the app router, I have a form submission, and that form submission can call a server action, which runs on the server. It goes to our server, it can update our database, it can revalidate our cache, and then it can return back the new UI as well as the data in the same network round trip in this RFC payload back to our UI. So there's some foundational differences here between how these two models work, and let's look at an example. Okay, so let's look at this to-do list example that's a bit more simple example from the first one that we showed. I want to walk through a couple different bits here. So let me make a new to-do, enter. That's going to submit the form. You'll see that the form went into that loading state, and then the new form was added. So on this page, we're fetching the to-dos from our Postgres database. Those get cached, and then I have this add to-do form that uses this hook called useFormState, which allows me to take some error back from my server action or some success message and display it on the page. In this instance, I'm using the response back from the server action to send a message to a screen reader, so in this live area. And also inside of here, I have this submit button. And the submit button is using another hook from React called useFormStatus. And useFormStatus is going to know when a mutation is pending. So when we're adding in a new to-do here, another to-do, when I hit enter and this goes into a pending state, you're going to notice that the add button gets disabled and we're able to then see that reflected in the UI. So let's take a look at what this action actually does. If I go into create to-do here, basically all it's doing is going to our SQL database, it's inserting some data, and then it's revalidating the path. And then it's returning that message back to the UI in the RSC payload, the React Server Components payload, so that you can use this. Now, the cool thing about this whole model is that it works even if JavaScript hasn't loaded yet. So for example, let's say that I want to go in here, let's say disable JavaScript, and I'll reload the page. And I want to delete this to-do. Great, that still works. I want to add a to-do. That also still works. And it also still works with useFormState. So you'll notice there was that browser loading spinner at the top because it's doing the normal HTML form reload where the page is reloading. So I think that's pretty cool. I also think it's worth showing what the network tab looks like when you're doing a mutation, when you're calling a server action and you're going to revalidate that cache data. So let's say I want to do another to-do here. I hit add, and we're going to see just this one network request. So I see in here that another to-do pops up. I click on this value, and I see that basically the server action is just posting back to itself. It's posting back to the same route. There's some additional information inside of here about the request. We can even see, if we go into the payload, we can see more about what's in here, what we set along to the server action, what the to-do was. It's called another to-do. And then the server, in this instance, returns back the UI as well as that updated state in that RSC payload. Now, going back to our first example with the roadmap product, I want to show another cool React hook called useOptimistic. And what I'm going to do is actually slow down our network here. So we're going to go to slow 3G. And when I showed it from the first time, everything felt really, really fast. But what happens if I was on a slower internet connection? Would this still feel really snappy? So I'm going to click upvote, and you're going to notice that I immediately see the 4 on the right side, but it took a while for the information to get updated. And if I look down in the network tab, I see that even though this waterfall, even though this request hadn't completed yet, I'm able to provide back feedback to the user right away using this optimistic UI pattern. And this also works too if I add a new item. So let's say another one, and I hit enter. I immediately see it show up. I immediately see the form field get cleared out. And then down below, I see, okay, that network request has completed. Now you might be thinking, well, what if my internet is really, really slow? So really, really slow. And a user submits this form, but then they want to close the browser tab. So they hit enter, and then they try to do a command W to close. Well, something I've added in here is just a little bit of JavaScript code that prevents them from leaving the site if they haven't made, or if this mutation hasn't completed. So it says, hey, are you sure you want to leave the site? In this instance, I'm going to say no. And then I see that my mutation goes through. And this only takes just a little bit of code here. So I have this use effect that is basically listening for this before unload event. And I can use that based on the pending state to know whether I want to pause and ask the user whether they want to confirm leaving the page. Now, going back up to my use optimistic pattern, I want to show something that was subtle, but very important, which is that this pattern still supports progressive enhancement. On the right in my browser, I've disabled JavaScript. And when I'm loading the page, if there's no JavaScript, or more commonly, the JavaScript hasn't yet loaded, this can still work. So in that instance, we're going to call the server action through the native form submission through the action. So if I click on upvote of new feature, I see the browser reload, and I see new feature here. The value goes up to 6. And because I don't have JavaScript, I don't get to have the niceties of the optimistic UI updates, but that's okay, because once the JavaScript has loaded, then I can use the client event handler, which is going to give me some additional enhancements to the flow. Now, it's worth mentioning that you might want to have a completely different pattern here, a completely different UX. If having JavaScript disabled is actually a very important requirement for your application, you might want a different UX where this redirects to some different page instead. But it's nice that you have the ability to craft that experience now. Okay, the last thing I want to talk about as it relates to caching and static and dynamic rendering is partial pre-rendering. Now, this is still experimental, so this is just an early look, but previously the way the Next.js Pages router worked was you had all or nothing static or dynamic pages. Either you could run your whole page and pre-render it as static, or you had to run it on demand. And I'll link a video down below and some additional information about partial pre-rendering, but just to show an example of what this looks like, I have my website on the right, and the majority of this page is static. But then I have this component where I'm listing out the number of subscribers, which it's a great time to subscribe to the Vercel YouTube channel if you haven't. And in this component, I want these numbers to be dynamic. I want them to be fresh. So in this application, I have the partial pre-rendering flag flipped on. The shell of my application, or the majority of this page, was pre-rendered as static. But then this specific component, I'm able to say, you know what, actually use no store, and we want this one to run dynamically. So if I reload the page, I'm able to run just that bit dynamically. And since the subscribers haven't updated, I can show a different example with my blog, which is where if I click in here, I'm able to get that new value and see it update in the top right. Okay, so that wraps up this video talking about fetching, caching, and revalidating with the Next.js App Router. Hopefully these demos and these examples help solve and answer some of your questions. If you still have open questions, please leave comments down below, or if there's things you want to see us make more content about, also just let us know. But hopefully this puts you on the right path to understanding caching in your next Next.js application. Peace.